All right, welcome back. Have you ever looked at a really complex design and just thought, how on earth did they do that? We're talking about arranging hundreds, maybe thousands of objects, like tiny gemstones, perfectly onto a crazy curved surface. Well, today, we're going to pull back the curtain on the parametric technique that makes it all possible. And trust me, it's a total game changer. Let's dive in.
Just look at this thing. It's incredible, right? The way these rubies just flow, perfectly hugging the curve of this ring. It's absolutely gorgeous. But it really makes you wonder, doesn't it? I mean, did someone seriously sit there and place every single one of those stones by hand? There has to be a better way.
And that right there is the big question we're tackling today. It's not just about jewelry either. Think about it. It could be architectural panels on a wild curving building, or even scales on a digital monster for a movie. The problem is always the same. How in the world do you handle that much complexity and keep everything perfectly aligned?
So the secret, it's not brute force. It's not spending weeks clicking and dragging. The solution is to think like a chef. You create a recipe, a smart set of rules that does all the tedious work for you. This whole approach is called parametric design, and I'm telling you, it will completely flip the way you look at creating complex patterns.
Okay, so here's our game plan. We'll kick things off with the surface challenge, then get our heads around thinking parametrically. After that, we'll hit the main event, the 4-step morph. Then we'll look at how it goes from code to creation, and finally, we'll talk about what this all means with Design Unleashed.
First up, the surface challenge, from tedious to seamless.
All right, next section, thinking parametrically. This is all about building the foundation.
So what exactly is parametric design? Well, let's stick with that recipe idea. Instead of, say, manually placing 100 stones, you create a rule that says, place 1 stone here. Then you add another rule that says, now repeat that 100 times following the curve of this surface. The best part? If you decide you want 200 stones instead, you don't start over. You just change one number, one ingredient in your recipe, and boom, the entire design updates instantly.
Okay, for this recipe to work, we have to understand how the computer, sees a surface. To you and me, it's a shape. But to software like Grasshopper, it's basically a numeric map called a domain. Just imagine stretching a piece of graph paper over the entire object. This paper has its own coordinates, not x and y, but u and v. And by knowing those u and v coordinates, we can tell our recipe exactly where on that surface to put stuff.
Okay, here we go. Section 3. This is the main event, the 4-step morph. Now that we've got the basics down, we're ready for the actual step-by-step process that's going to let you conquer basically any surface you can throw at it.
And you know what? The workflow is actually super straightforward. It boils down to these 4 steps. First, we divide the surface domain. Second, we generate subsurfaces. Third, create target boxes. And fourth, we morph the geometry. Basically, we make a grid, chop the surface into bits using that grid, put a box on each bit, and then squish our object into every one of those boxes. Let's look at each one.
So, step 1, divide the surface domain. This is where we create our grid. In Grasshopper, we use a component called divideIntervalSquared. All this does is take that numeric u and v map we talked about and slice it up into a grid. And what's really key here is that we're not actually cutting the physical surface. We're just drawing a grid on top of its coordinate system.
Okay, on to step 2, generate subsurfaces. Now we take that grid we just made and plug it into a component called isotrim. You can think of isotrim as a little cookie cutter. It uses our grid to stamp out and extract tiny, individual patches of the actual surface. So, just like that, our abstract grid becomes a bunch of real, tangible little pieces of our original surface.
Step 3 is all about creating the target boxes. We've got our little surface patches, right? Now we use a component called SurfaceBox. And what it does is, well, exactly what it sounds like. It builds a 3D box right on top of every single one of those patches. These boxes are going to be the new homes for our objects. And what's cool is we can easily control their height, which lets us decide exactly how far the objects will stick out from the surface.
And here it is, the final step. And honestly, this is where the magic happens. Step 4, morph the geometry. We use a component called BoxMorph. It does something amazing. It looks at our original object, our gemstone or whatever, inside its own invisible container, its own bounding box. Then it takes that object and perfectly stretches, bends, and deforms it to fit inside every single one of those target boxes we just made on the surface. It's like pouring a liquid from one container into 100 others all at once.
And there you have it. This is the perfect before and after.
On the left, we start with our single object and a totally blank surface. On the right, after running our 4-step recipe, bang! The entire surface is covered in a perfect flowing array of that object. It's just so powerful.
All right, let's move on to our next section, from code to creation. Let's actually look at what this recipe looks like in Grasshopper. So this is it. This is the whole engine right here. It might look a little intimidating, but it's literally just our 4 steps, connected together. You can see the data flowing from left to right, from the component that divides the surface, to the one that makes the patches, then over to the one that builds the surface boxes, and finally into that box morph component that does the final transformation. It's our recipe laid out visually.
I love this quote because it just nails it. So basically, the idea is simple. We produce a module, design our general surface, generate boxes, and then we morph the module into these boxes. And that's really all it is. Don't let the components and wires fool you. At its heart, the idea is incredibly simple and elegant.
And of course, things can get even more specialized. For a really specific job, like that gemstone ring from the beginning, there are custom tools out there that take this concept even further. You might find a component called something like pave to surface that basically automates this whole 4-step process just for gemstones. And it even takes care of all the tricky spacing you need for fine jewelry.
Okay, that brings us to our final section, Design Unleashed. Let's talk about the real power of this recipe-based thinking.
So why is this such a big deal? Well, first off, flexibility. It's insane. Want to go from 100 to 500 objects? You just move a slider and it's done, instantly. Second, the efficiency is off the charts. You're automating something that could literally take days of mind-numbing manual work. And finally, complexity. This approach makes these incredibly beautiful, intricate, flowing patterns totally achievable on pretty much any surface you can dream up. It just opens up a whole new world of design. Look, when you stop thinking about placing one object at a time and start thinking about creating a system, a recipe, you gain a level of creative control that's just liberating. So really, the only question I have for you is this. Now that you know the recipe, what are you going to create?